Hello, everybody. My name is David Wilson. I'm the product manager at SOR for pressure and temperature products. What I'm going to talk about today is just an overview of oil and gas applications that SOR typically plays into. So we'll go ahead and get started and roll in here. So the agenda for today. First off, I'm just going to kind of overview the major components of the oil and gas process and industry, and then we'll move on to some of the specific applications within that process that SOR really sells our instruments into. So we'll start with the wellhead, and then we'll move into the stage 1 separation, and then we'll talk about the products used in stage 2 separation. And then we'll wrap up with the wireless RTU and data acquisition applications that SOR typically sells into. And then I'll kind of do a whole conclusion and wrap up of everything that we talked about. So moving to the overview of the oil and gas process. Typically, you can break the oil and gas industry into 3 components. There's an upstream component, a midstream component, and then a downstream component. And so when we define those, upstream's really searching for the product, finding the product, and then producing it, and preparing it for pipeline transmission. Whereas midstream is actually moving the product from the place of discovery and from the wellhead to where it's actually going to be refined and used. And then downstream is where you actually treat and refine that product into multitude of different products. So SOR usually focuses all of our instrumentation to the upstream. There are applications in midstream and downstream, but for this presentation I'm going to focus on the upstream production side of things. As far as midstream applications, compressor stations, slug catchers, and pig launchers are some examples. But as I said, I'm going to focus on the production side of things. So what is production? Defining production, it's the process of extracting hydrocarbons to the surface through the well and separating that mixture into liquid hydrocarbons, gas, and then a mixture of water and solids as well. So during this process, the goal is to remove anything that can't be sold and to pump that away and separate that from what can be sold. And then you take what can be sold and you transmit that to the downstream applications. So whenever on production control systems, they're very important for the production side of things in order to keep the process within its design constraints. So this requires, reliable control system, reliable control equipment that feeds that control system, just to make sure everything's efficient and safe. A part of a control system is an emergency shutdown system, which will take action if that process ever gets out of design constraints. It will alter the process to put it back within design. It will shut down the system or alter the process to put it back within design constraints. So typically what's feeding an emergency shutdown system is some sort of alarm where you've got a low alarm. Possibly at the bottom of the tank you've got a level switch that flips an alarm if the level goes below. You've also got a low alarm, which is more of a warning, and then a high alarm, which is a warning of high. And then you've got a high alarm, which actually throws off an alarm and shuts down the system. And so these are the types of systems that our instruments are used for and feed the inputs to. As far as the overview of all of the applications we're going to talk about, here's an illustration that sort of places all of our products throughout the production process. You can see I've separated it into 3 different categories, starting with the wellhead. This is really where you're finding the product and you're pumping it out of the ground. And then stage 1 separation, and then I've separated it out into stage 2 separation and storage. So this is a great image of all of our products placed throughout this, the process. So the first thing I'm going to talk about, I'll start with the wellhead applications. On most wellheads, the main instruments we're going to use are going to be pressure transmitters and some temperature sensor assemblies. The applications, casing and tubing pressure, borehole pressure, and lubricator outlet pressures. So the casing and tubing, the casing is really the backbone of the wellhead. It's what's keeping everything stable as you're pumping the product out, and the tubing is where the product is actually being pumped through. Lots of times the casing and tubing pressure are measured to operate the auxiliary equipment like compressors and pumps. If one of those pressures gets out of its design constraints, then usually they'll shut down the pumping or the compressing. And then as well as that, these pressures are used in the proper timing of a plunger lift system. And so basically what the plunger lift system is doing is it's a clean and efficient alternative to a wellhead blowdown, where in the past what they would do is they would allow the liquid to build up pressure, and then they would open up a valve that would spray that liquid and a little bit of gas into the atmosphere and relieve that pressure. So with some of the focus on being more clean and efficient now, lots of times you'll see a lubricator plunger lift system put in place. And what that does is instead of releasing that waste to the atmosphere, it'll instead have a plunger that's set at the top of the wellhead, and then whenever the pressure is sensed to be too high because the liquid's clogging it up, that plunger will fall to the bottom and the pressure will build up, and then what it'll do is it'll push that plunger all the way back to the top of the wellhead, and all of that excess liquid and gas that I talked about before that would normally go to atmosphere is instead piped off into a different location, and it's not released to the atmosphere. And so they'll use casing and tubing pressures and borehole pressures to make sure that all the proper timing of that lift system is happening. Some of the other uses of monitoring these pressures is to provide the pressure values that are used in a flow meter or a flow calculator, just to get a gauge of how much process is actually flowing through the wellhead. And then also record keeping, just keeping track of how efficient the wellhead is and how much it's producing over time. And that really helps the operators decide what sort of actions they need to take to keep the wellhead operating efficiently. So the next part I'm going to talk about is going to be the stage 1 separation. So the process has been pumped out of the wellhead, and now it has been moved on to the first stage separation. And what I have here is an example of two-phase separation, which is where you're breaking it down into gas and then liquid, but you're not yet separating the liquid into water and oil. And so what you can see in this illustration is the process, the pressure is decreased in this chamber. So there's a pressure decrease. And what happens is the gas separates from the liquid, and it passes through a mist extractor at the top to separate as much moisture as possible. And that gas will then exit through the outlet up here. You can see we've got a thermal differential flow switch, which can be used to set some sort of alarm if there's not enough flow for the pump that's moving gas out of that separator. If there's not enough flow, it'll shut down that pump, and so you're not damaging that equipment. And then off of that, the gas will, sometimes it'll be passed on to be treated before it's sent through midstream, but usually it's just sent straight onto a gas processing plant if there's no concerns over H2S or water in the natural gas. And moving down here, you can see some of our other equipment. We've got a pressure transmitter keeping track of the pressure in this separator. We've got a high level alarm with our 1500 series level switch. And then an MLI here gives us a visual indication of the process, so the operators from the outside, they can use that MLI to visually see where the level's at. They can also compare that level with any sort of electronic outputs they're getting, if they have some sort of electronic level transmitter. We keep track of, give visual indication of the separator temperature with the bimetal thermometer. And then everything you see over here on the right side is our pneumatically controlled dump cycle equipment. And what this is used for is to make sure that whenever the level gets high enough, the 1600 series level controller will tell the dump valve that it's time to dump some of that process onto the next stage of separation. And so feeding that liquid level controller, we've got some regulators here doing a staged regulation of the gas that I mentioned earlier, which is at a high pressure. We'll do a first cut pressure break with a 1201 HP regulator, which is rated to 5,000 psi. And then that passes on the pneumatically controlled gas to the next stage of regulation, which will be a 1200 series pressure regulator. These products are coming soon, planned to launch in Q1 of 2018, but for now, this regulator is not yet on the market for SOR. And then out of that regulator, we'll do one more cut through an air filter regulator, which cleans the gas and then regulates it down to the final control level for the liquid level controller. And so on this page, I've listed off kind of what I just explained, but these are some of the applications that we're keeping track. I mean, we're monitoring the inlet pressure, the separator pressure, monitoring the inlet temperature with another temperature assembly like we saw in the Wellhead application illustration. And then we're giving local indication for temperature and level. Continuous monitoring of separator level can be used with a 815 DT or a level transmitter. And then we also provide equipment that will give high and low separator level alarms. And then that T21, like I mentioned earlier, it's what's controlling the gas outlet pump and making sure that that pump isn't running at a time where it could damage itself. And then the regulators and the liquid level controller and dump cycle all work together to provide a pneumatically controlled dump cycle. So what do these applications really give the operator? Well, record keeping and efficiency planning kind of goes in line with what I mentioned before on the Wellhead. Using these electronics and recording the output of those electronics, the operators are able to design, process planning to make sure that everything is going efficiently and safely. The local indication gives the operators confirmation of the analog output of these electronic instruments. And then also lots of these instruments are feeding the emergency shutdown control, like the 800 series pressure transmitters and the 1500 series level switches. Those can be feeding an emergency shutdown control that will provide a safety net in case anything gets out of control. It'll shut the process down. And then equipment protection, I talked about that already with the T21 protecting the pump. And then you're getting a controlled and efficient dump cycle with all of the regulator and liquid level controller and dump valve products used. And then this is an example. This is still a first stage separation example, except now this is an example of three-phase separation. And what's happening here is you're still getting the flow from the wellhead. You're still decreasing the pressure. But what's happening here is the gas is being separated, and then the oil and water are being separated at the same time in the same tank. Really all the same equipment is used here, so I won't dig into that too much. But it's just another form of first stage separation that can be used. So the next stage of separation is what I'll talk about now, and then I've included storage in here as well. And so in the second stage of separation, we see some of the same equipment in a separate tank. But what's happened here is you've got another pressure decrease into this chamber, which allows that oil and water to separate. And you're still giving visual indication. With the MLI, you're still giving high-level alarms and low-level alarms with 1500 series level switches. And then you're still controlling the dump cycle. And this air filter regulator right here, it's getting its input at the same point as the other air filter regulator. And then over here in the storage tank, you can see we've got a level transmitter that can be submerged into the water tank to keep track of the level. And then also another series of level switches for high and low level alarms. And so really the main reason that you'd want multiple stages of separation is for stability in your process. If you try to do too large of a pressure decrease at once within the production process, you could get flash vaporization, which could cause instability in the product, and then also some safety concerns. So really that's the main reason to do multiple stages of separation. And really here the applications and results are identical to the phase 1 separation. It's just a different phase of separation, but you're still using the same equipment and getting the same results. I've included some pictures here of some of our products that you can see. And this one down here I'd like to highlight is our new submersible transmitter, which is in the works. I'm not saying it's launched yet, but I just want to give you guys a heads up that there will be a new submersible transmitter option for SOR sometime next year. So the final application I was going to cover through this process is going to be wireless RTU and data acquisition. And so more and more often today we're seeing a move to wireless transmission of the data from pressure transmitters and other electronic devices. This is really ideal for remote locations where it's too costly to trench and run wire for a wired transmission system. And so what a wireless RTU data acquisition system will do is it's going to eliminate the manual processes required to check the system through local indication. Lots of companies now, what they do is they have an operator that will drive out to the location of the wellhead or the production site, and they will check all of the local indication like the thermometers, the pressure gauges, MLIs. They'll check the local indications, and then they'll keep a physical record of those local indications. And then they'll drive back or they'll drive to another site and do the same thing. And so you get a lot of cost savings because you're not spending money on running that guy out there, and you're not spending money on the gas and his time. And then also you're saving money on the wiring and the trenching. So it's more cost effective and it's faster to install. And then also you get a remote monitoring and control of the system from a remote location or remote control site. And so this is an example over here that we've got a picture of our 815 pressure transmitter. I think this is on a separator tank. And what it's hooked up to is a solar-powered telemetry system on top. And what this will do is it'll send its data to the RTU data acquisition central location on the site. And then you can see this guy has a little bit larger antenna, and that's going to be sent to the actual control system. But everything's powered through solar power and batteries, and you don't have to run any wire or cable to keep it powered. So that was about all of the applications I wanted to cover. I'll go and conclude here. Really the main thing to remember is SOR products for oil and gas, they're usually applied to upstream applications. As I mentioned, we can sell our products into other applications, but what we typically see sold into the most is production applications. And that's really what we're targeting with some of the products that we're coming out with, the new regulators, with the dump valves and the liquid level controllers. We're targeting a complete package solution for our customers where they can come to one place and get all of the products that they need for their separation and production package. So throughout the entire production process, SOR provides rugged, reliable products that the operators can count on to monitor the process and keep it within its design constraints. Most of our products can be used to feed a control system, which is really protecting the production from safety concerns and also keeping it operating efficiently and maximizing savings and profit for the customer. So really that's all of the applications I had. If you wanted more information on the SOR products, then please follow the links in the description or contact the factory. There will be a description under this video on YouTube that'll have links to the products that you guys can check out. For other inquiries about price and lead time, please contact your customer service representative. And then finally, be sure to subscribe to our YouTube channel if you want to see more videos about SOR products. So that wraps it up for me. I want to thank you guys all for joining. If you have any questions, please feel free to type it into the chat, and I'll respond to you. Thanks.